Welcome to the first video that you are watching as a pre-calc student in my class. In this video you're going to see a list of a bunch of skills from Algebra 1, Algebra 2 that you'll need in order to be successful in pre-calc. It's not a complete list, but it's a really good place to start. So what I want you to do for this video is, as problems pop up on the screen, I want you to pause the video, write them down, try the problem, and then press play to see if you got them right. We're going to start with solving equations. You guys have done tons of equation solving ever since middle school or so, and that skill is really important if you want to be successful in pretty much any higher level math. So let's get started with that, and then we'll move into factoring quadratics, solving quadratics, and then working with square roots. So here we go. Let's go to our first example. Solving equations with rational coefficients. Pause the video, give this a shot. Starting pretty simple here, so you should do fine. When we say rational, of course, we're talking about fractions. So when we have 3/5 times some number equals 10, what I want you to do is, you're technically going to be dividing by 3/5, but a little shortcut here, just multiply by the reciprocal on both sides. These cancel over here, leaving us with x is equal to 50 over 3. And that is a completely fine answer. I don't really need to turn it into a mixed number or a decimal or anything like that. I'll keep it like that. Next up, solving equations with variables on both sides. Pause it, give it a shot. Again, pretty simple. This is, of course, the distributive property. You see a number outside of a binomial or a polynomial of any sort, you just multiply it by everything that's on the inside. So let's distribute first negative 3x plus 15, and now we have variables on both sides. So my strategy for that is to locate the x term with the bigger coefficient, which is 8 in this case. Keep that where it is and then move the other one over to it. In other words, if it's a negative 3x, we want to move that over to the left. So you have to do the inverse operation of negative 3x. Those will cancel. 8 plus 3 is 11. Subtract 6. 15 minus 6 is 9. And your answer is 9 over 11. Again, that's an exact answer. I don't have any interest in turning that into a decimal. We'll leave it like that. Next up, solving equations that are basically two fractions is essentially like a big proportion, but what you're looking at here is we have a negative sign right here. I'm just going to basically apply that to the top. So I'm going to rewrite this. Negative x plus 8 over 11 is equal to negative 6 times quantity x, negative x plus 4 over negative 2. And all we're going to do here is basically cross multiply. So I have 11 times negative 6, which is negative 66. And I keep my parentheses. Negative 2 times that binomial, put that in parentheses as well. Now we're distributing on both sides. So we have positive 66x minus, let's see, that's 240 plus another 24, 264, I think. Let me check that. Let's see, 24, 240, 264, yeah, that works, is equal to positive 2x minus 16. Again, anchor the bigger x term where it is and move the smaller one over. So I'll move that over here and rewrite everything else. I'm going to add 264 to both sides. 264, excuse me, negative 16 plus 264. Well, those are different signs, so I'm just going to subtract them. And let's see, we're going to get 5, and we're going to get 8, and we're going to get 248, positive 248. And we're just going to divide everything by 64. So I end up with 248 over 64. This is reducible, so I'm going to basically just recognize that They're both even, so let's cut them both in half. 1, 2, 4 over 32. They're still both even, so that means I could have taken a 4 out initially, but that's all right. 62, I'm going to cut them both in half again, over 16. They're still both even, so I'm going to take another 2 out. 31 over 8, and that is irreducible, so I'm done. Cool. Let's move on into factoring quadratics. Start really simple here. This is Algebra 1 stuff where the lead coefficient is 1. We're basically looking to find the two binomials that multiply together to get that quadratic. So we need to think, all right, x times x. We're kind of like thinking FOIL method backwards here. The first terms multiply together to get x squared, and let's go to the last term and we'll really think about the factors of 6, 1 times 6 and 2 times 3. So I need to pick a pair of those factors that add up to our middle term, and you can see 2 plus 3 not only multiply, 2 and 3 not only multiply to 6, but they add to 5. This is going to be a plus here and a plus here, and to check that, just use your FOIL. So we'll go first times first, outside, inside, and last. Combine these two, you get 5x, and that works. Same thing down here. Let's figure out binomial factors of this quadratic. First times first is x and x. This time we have 12, so 1 times 12, 2 times 6, 3 times 4. But you'll notice the signs are a little different here. We have a plus minus, which means that our signs in here are going to be different. One's going to be plus, one's going to be minus. So we're looking to find a pair of these factors that now subtract to that middle coefficient, which is 1. So you can see 4 and 3 certainly subtract to get you 1. If the middle term is positive, the bigger number down here will be positive. And you can check that by foiling. I'm moving on to factoring quadratics with a lead coefficient that is bigger than 1. So in this case, again, we're looking for the binomials that multiply together to get this trinomial. And it's nice when the lead coefficient is prime because you don't have any other options. It's 5x times x. When you multiply those two together, that gives you 5x squared. The last number is 6, so you want to just make a quick list of the factors of 6, and you're just going to kind of plug them in here and figure out which two sort of combine together with the 5 and add up to the middle coefficient. Now, some of my students in the past couple years have showed me some sort of crisscross method, which I don't really understand. If you know the crisscross method or any other method, diamond method, use those methods, but the way that I basically go about this is just the old-fashioned way. I just like to put the numbers in here and kind of think about, you know, if I put a 2 here and a 3 here, and I know that if there's a minus first and a plus second, then it's going to be minus minus down here, and I'll just kind of see if that fits together. Outside is negative 15, inside is negative 2. That does not add to negative 11. So maybe I'll switch the 2 and the 3 around, see if that works. So the outside now is negative 10, the inside is negative 3. That doesn't add up to negative 11 either. So that means that 2 times 3 is not the correct combination of factors. So I'm just going to throw in 6 here and 1 here. So now I'm going to check this. First times first is 5x squared. Outside is negative 5x. Inside is negative 6x. Last is 6. The O and the I combine and we are finished. So the binomial factorization is in yellow. Moving on. Factoring quadratics that have two variables. So in this case, again, we're looking for the binomial factors, the two binomials that will multiply together to get this quadratic. And we have a number in the front that is composite, so we have options, and we have a number in the back that has options as well. So that leaves a bunch of different combinations that we have to sort of consider. I really don't know the answer to this. I haven't figured it out beforehand, but I'll just pick 2 and 3 and 3 and 4. As a general rule, in my experience doing these problems for the past many years, it seems that the factors that are closest together are usually the place that you want to start with. So let's just put the things in there: 2x and 3x and 3y and 4y. So the interesting part about this problem is that there's a y squared at the end. So that means that your last terms have to have y in them. They each have to have y in them. So let's check this. Again, I don't know the answer, but this is a minus, this is a minus, so I know that these have to be different signs down here. So let's just put in a plus and a minus and we'll see what happens. So first times first, I'm just checking this. 6x squared outside is negative 8xy, inside negative 9xy, last negative 12y squared. So if I combine these two middle ones, I get plus xy. And I can see that I'm pretty darn close to what I actually wanted. I wanted a minus xy in that middle. So let me just try to put this as my plus. So that changes, it doesn't change the first term, it changes the outside to positive 8xy, changes the inside to minus 9xy, and it also changes that to negative xy. So that'll work. So the binomial factors of my quadratic are in yellow. And again, if you know some sort of fancy method, some sort of trick, some diamond method or crisscross or whatever, use that. I don't really know those though. Moving on. We have a difference of cubes. In this case, difference of course meaning subtraction, and a cube, a perfect cube, meaning there's something there that is x times x times x, and something there that is 2 times 2 times 2. So it's difference of cubes has a fancy little formula here, and the formula is that when you have a difference of cubes, you want to factor it, so it's x minus 2 and then x squared plus the basically just the 2x there, and then the last term is 2 squared, which is 4. So let's check that to make sure that we're good to go. So I go and basically distribute this binomial into all three of these terms, and we'll see if our little formula works. So it's x squared times this little quantity plus 2x times this little quantity plus 4 times this little quantity. In other words, this binomial sort of gets distributed or spread out among all three of the terms in the quadratic, in the trinomial here. So let's see, we got distributive again, so that's x to the third minus 2x squared plus 2x squared minus 4x plus 4x minus 8. And I'm checking to make sure that this formula that I used here is the right one. Sometimes I forget them, so let's see. X cubed doesn't come out with anything else, so we'll write it there. Negative 2x squared, positive 2x squared, they cancel. Minus 4x plus 4x, they cancel, leaving us with minus 8, which is exactly what we wanted. Alright, so that tells me that my formula is correct. So we've got this as our binomial, as our factors of x cubed minus 8. Alright, moving right along, we've got a sum of cubes. So how do you factor this? Well, you have to know your formula again, and your formula for the sum of cubes is going to be similar to the last one, but generally speaking, if you have a 64, this is 4 times 4 times 4, this is x times x times x, and this is 5 times 5 times 5. So generally speaking, if you have something like this, the formula says that you take that 4x plus 5, and then the rest of it is the a term, which is 4x squared, so we'll put that in parentheses, minus 4x times 5 plus the last term here squared. So let's clean that up a little bit and then we'll check it to make sure that we got the right formula down. 4x squared, quantity 4x squared is 16x squared minus 20x plus 25. So let's check that. When we check, we basically just want to take, as I said before, take this and just distribute it into all three terms. So let's see what happens here. We've got 16x squared times 4x plus 5 minus 20x times 4x plus 5 plus 25 times 4x plus 5. And we'll just do three little mini distributive property problems, and we're just checking to see if our formula is correct. 16 times 4 is 40 plus 24 is 64x to the third plus, let's see, 16 times 5 is 50 plus 30 is 80 x squared. I'm going to move this thing over a little bit. Negative 20x times 4x is minus 80x minus 100x plus 100x plus 125. So the x to the third power doesn't get combined with anything, but you can see that there should be a squared right here. Negative 20x times 4x is negative 80x squared, and you can see that they cancel. Minus 100x plus 100x, they cancel as well, leaving us quite simply with exactly what we started with. Alright, so that tells me that right down here, let me get rid of these things now. That tells me that that is the correct factorization of what we started with. It's called a sum of cubes. We're going to use that in pre-calculus. Moving on. So now we're not just going to factor quadratics, we're going to solve them. This is a quadratic that does not have a linear term. If you wanted to sort of expand this out into a traditional quadratic looking formula or equation, it would be 0x in the middle. X squared minus 25 equals 0 is actually, there's a 0x as the linear term, but of course we don't need to write that. So what I'm going to do is just simply get that 25 over. I'm going to take the square root of both sides. When you do that, you have to think about the principal root and the negative root. So you have to take both the positive and the negative. So the answer to this is positive and negative 5. And the reason that you have to use both of those roots, the positive and the negative root, is because, think about it, some number times itself is positive 25. Well, let's check. What's 5 times 5? Does that equal positive 25? Yeah, it does. But what's negative 5 times negative 5? Doesn't that also equal positive 25? Yes. So you have two answers here, and you have to account for both of them. Next up, we've got quadratics that are factorable. So we're just going to factor these and use our, I think what they call the zero product property. So x and x and 4 and 2, and this is minus minus, so this has to be one of each sign. If the middle one is negative, the bigger one down here is negative. So once we have that factorization, you might want to check it by doing the FOIL method, first outside, inside, last, and you do in fact see that the factorization is correct. But that's not where we stop. We stop when we actually have solutions. We're trying to figure out the x values that make this equation true. And to get that, we basically branch out into two separate equations. This is called the zero product property. It basically says that if two things multiply together to get 0, that means either this one is 0 or this one is 0 or they're both 0. So let's simply solve each one of them separately, and we see that you get two solutions. There you go. How about what happens when we have quadratics that are not factorable? And this is a case where, you know, if you try to do the factorization, you wouldn't come up with any answers. So we have to think about how to solve this thing using our good old quadratic formula. Now, the quadratic formula you've learned in Algebra 2 is negative b plus or minus b squared minus 4ac all over 2 times a. And we get these letters from our equation, right? It's usually ax squared plus bx plus c equals 0. So it's probably a good idea to over here just list our a, b, and c constants, a being 7, b is negative 8, and c is negative 17. And then we just plug them in where they belong. So our solution is negative b, which is actually positive 8, plus or minus b squared, so it's negative 8 squared minus 4 times a times c, 2 times a. And we just clean it up. Positive 8 plus or minus 64. In the middle here we have minus 28, negative 28 times negative 17. So let me multiply that out. Let's see, 56, 14, 19, 0, 8, 2. So that's 6 and 7 and 4. 476. Looks like a winner to me. That's going to be positive 476. So let me get rid of all this so it's not too confusing. And it'd be embarrassing if I made a mistake there, but I don't think I did. Over 14. So let's clean up that inside. That's called the discriminant or the determinant. I think the discriminant. Sometimes I forget those two. But it's 8 plus or minus this inside radicand, which is 476 plus 64. You're noticing that I'm doing pretty much all my arithmetic without calculators, and I like to do that just to stay sharp. So 6 plus 4 is 10, so that's 8, and 6 is 14, that's 540. Divided by 14. Okay, so we have a situation here where we want to kind of branch out here. So what I'm going to do is sort of branch out into two solutions. One of them has a plus right here, and one of them has a minus right here. And that 540 as a radicand, I'm thinking probably has some perfect square in it as a factor. I don't really know the answer to this, to be honest with you, but I'm going to work through it right now as we go along here. So I'm thinking about factors of 540. It's definitely even, so that means that we can divide it in half. And is it divisible by 3? Let's check. I forget my divisibility rules, so I'll just check that. 3 times 10 is 30. 54 minus 30 is 24, so that I think that's going to be 18 with a 0 at the end. So 3 times 180. Don't see any perfect squares quite yet. So does 4 go into 540? Let's see, there's a 1 and a 14. No, that doesn't work. 5 definitely goes into it, I know that much. So it's going to be 108, I think. Again, I don't see any perfect squares yet. How about 6? 6 definitely goes in there. 6 times 9 is 54. So the answer is 6 and 90. Again, I don't see any perfect squares. How about 7? 7, does 7 go into 50 or 540? Well, it'd be 7, so it's 49 and 50. No, that doesn't work. How about 8? Does 8 go into 540? 8 times 7 is 56, so this is 6, 48, and 60. No, that doesn't work. We definitely know 9 does. 9 times 6 is 54, so 60. There we go, there's a perfect square. 9 is a perfect square, so I'm going to break my 540 down into 9 and 60. So let's do this. 8 plus radical 9 times 60 over 14. 8 plus radical 9 times radical 60, split them up. And keep going. Radical 9 we know is 3, so it's 8 plus 3 radical 60 over 14. But I also know that I can probably take this one step further. All right, 60 I think about as having factors as well. 60 has factors 1 times 60, 2 and 30, 3 and 20, and 4 and 15. 4 times 15, 4 is a perfect square. So we're not quite done yet. So we're going to break 60 up into 4 times 15. And this might seem sort of tedious to you, and you might be tempted just to go right to your calculator. But I encourage you to know how to work with these radicals, and I'm purposely going through this step by step to show you exactly how much work I'm willing to do on these problems, and you should be the same. 8 plus, I broke radical 4 down into just 2, so that turns into 8 plus 6, radical 15 over 14. Now watch this, we've got 3 numbers that are outside of our radicals. If you can simplify those, you have to. They're all even, so let's cut all of them in half. And that it represents one solution to our quadratic. So long story short, if we're looking at the square root of 540, which is what we started with, the square root of 540, if you saw that it breaks up into, if 9 times 60 works, then 540 should break up into, instead of 9 times 60, I think 36 times 15 would work as well. So let's check that. 30, so that's 15, 180 placeholders. So yeah, this looks like, if you saw that the factors of 540 were 36 and 15, that would probably save you 2 steps there, or save you 1 step. You can basically do that in 1 step if you saw that. But again, I didn't know the answer, and I don't know the simplification of 540 off the top of my head. So I wanted to prove to you that, you know, you can do this stuff without a calculator, just going through it, finding factors, and go from there. So we can simplify this. We've said that 540 breaks down into 6 radical, what was it, 15, right? Right down here, 6 radical 15 is equal to the square root of 540. And that comes from the square root of 36 times the square root of 15. So we just put that up here, 6 times radical 15 over 14. The only difference between the 2 branches is this sign in the middle. Again, they're all even. When they're all even on the outsides, you can, or you have to cut them in half. So we have 4 minus 3 radical 15 over 7. And that's the other solution. So let's bring that thing down here with its partner. Those are your 2 solutions to this quadratic. All right, so learning how to work with that quadratic formula is something that you learned in a previous class, definitely Algebra 2, maybe even some of you Algebra 1. But it's really important to know how on earth we solve these quadratics without, when they're not factorable. And in this case, we had a lot of radical simplification to work with. Now this is going to come in handy because when we get to quadratics in Pre-Calc, and maybe you did some of this last year, but we're going to work a lot of times with solutions that have imaginary numbers. Sometimes these solutions right here will be complex numbers, and that's going to basically be when your parabola resides completely above or completely below the x-axis. Those are imaginary solutions, they're not real solutions. So all this stuff is going to come back into play over this school year. Next up is going to be a review of radicals. All right, we did lots of it right here, but now I'm going to get into radicals, and we'll start with simplification, which we just did a little bit of, and then get into arithmetic and rationalization. All right, let's get into our radicals, or our square roots. In this class, we're going to be working with radicals when we get to some polygon stuff, and when we get to some special right triangles and stuff like that. So it's important to know how to do this stuff. We'll start with simplifying. So write this down: the square root of 147. Without a calculator, simplify this into its most simplest form. And to do that, what you want to do is basically break that number up into factors. So we want to think about, all right, what numbers multiply together to get 147? Well, it's 1 times 147, of course. It's not even, so 2 doesn't work. Let's see if 3 works. Does 3 go into 147? Let's see. We've got 3 times 4 is 12 and 27. Yeah, 3 times 49. And that is kind of like a really, really good thing, because I noticed that, I'm going to write it like this, 49 times 3. I noticed that 49 is what we call a perfect square. A perfect square, of course, is a number that is the result of 2 numbers multiplied together to get it. 49, of course, is the product of 7 and 7. And when we work with radicals, we always want to be thinking about perfect squares. So here we go. I wrote 147 as 49 times 3. One of our radical rules is that we can break that up into 2 separate radicals. The square root of 49 is just 7. Get rid of the radical. Radical 3 we don't know. And that's our answer. So this guy is equal to this guy. But the one at the bottom in yellow is what we call the simplest form. So if you were to put those both into your calculator, this guy and this guy, you get the same decimal. But in mathematics, you always want to have the ability to write radicals in their simplest form without using decimals. That's, of course, an exact value. What happens when we try to add radicals together? We have this number in here is called the radicand. When they are when they are the same, you can just simply add them together. But you don't want to add, it's not, you don't do this. It's not 3 plus 3 is 6. That's not true. All you do is you think about this as like one thing plus another thing that's the same thing. So when you add 1 plus 1, you get 2 of those things. That's all. And that's your answer. So 1 radical 3 plus 1 radical 3 is 2 radical 3. It's pretty easy. What happens if you have something like this? Bring this right here. We got ourselves 2 radical 20 plus 3 radical 2 plus 3 radical 8. Alright, so we don't have, if you look at our radicands, we don't have like radicands. So right now we can't just add these together. So our first task is to get all of these radicands to be the same. And this is kind of our clue. 2 is of course, it's a prime number. You can't simplify that anymore. So that might help you to figure out what you need to simplify these two radicands to be. Can we change radical 20 into something with a base of 2? And I think we probably can. Let's see. We got, all right, 20, the factors of 20. Here's what we want to do. We want to say, all right, 1 times 20, 2 times 10, and 4 times 5. So 4 times 5, that's a pretty good deal, because that is what we call, of course, a perfect square. So I'm going to break this down. I'm going to break radical 20 down into 4 times 5. The 2 just gets put out in front, sort of like a coefficient. Plus 3 radical 2, that can't change. Plus 3, and then I want to break radical 8 down into something. Well, the factors of 8 are 1 times 8, 2 times 4. Again, we've got ourselves a perfect square right there, so that's a pretty good indicator that that's what you want to use. So break 8 down into 4 times 2. So here we go, 2 times 4 times 5. Break those up. Plus 3 radical 2, plus 3 radical 4 radical 2. 2. The square root of 4 is 2. So we're actually performing that operation of square root. Get rid of the radical sign once you do that. Radical 5, can't do that. Plus 3 radical 2. Plus 3 times the square root of 4 is just 2 times 2. Simplify, 2 times 2 is 4. Radical 5 plus 3 radical 2 plus 6 radical 2. And here we go. We have radical 2 terms that can be added together. Remember one of our previous examples there, right above, we said 3 plus 6 is 9 radical 2. 4 radical 5 doesn't have the same radicand, it doesn't have the kind of the same base thing, so you can't add them together. So this would be a final answer right there. No calculators needed, pretty simple stuff. And by the way, you know you're finished when both of your radicands are simplified and there are no longer any perfect square factors inside of it. What happens when you multiply? When you multiply radicals. So when you multiply radicals, the rule is pretty simple. You want to multiply the things on the outside, so 5 times, there's a 1 here, so 5 times 1. And then multiply the things that are on the inside. So I'm going to change it to look like this. I'm going to move them both inside. 2 times 2 is 4. The square root of 4 is 2. So my answer is 10. And that little trick kind of works for everything. If you have like radical 7 times radical 7, that's just equal to 7. Radical 10 times radical 10, that's just equal to 10. Alright, the square root of something times the square root of that same thing is just equal to the thing. It's kind of like a basic rule. How about something like this, some division? Well, for this particular problem, I'm looking at the denominator and I'm saying, oh, I know the square root of 16. The square root of 16 is a nice, easy number. The square root of 16 is 4. Let me rewrite that. 4 radical 15 divided by 5 times 4. All I did there was I said, all right, what number multiplies together to get 16? And it's 4 and 4. So I write that down there. Notice the radical disappears. 4 is on the outside and it's in the top. It's down here, you can cancel them. So it's radical 15 over 5. And that's it. That's a finished answer. No calculators needed, no decimals, no craziness, pretty easy. What happens when you have this though? We've got ourselves a division problem. The square root of 4 I know is 2. Square root of 3 I don't know. This is one of those sort of tenets of mathematics. You cannot leave radicals in the denominator. Not allowed. So in order to sort of eradicate that and get rid of that radical, we're going to perform a little trick here called rationalization. We're going to rationalize the denominator. When you rationalize a denominator, you basically just multiply top and bottom by that denominator. And what that leaves you with, I'll write it down here, in the top is 2 radical 3, the bottom is just 3, and you're done. That is actually equivalent to this. If you were to put it into a calculator, you'd get the same decimal, but the one that's in yellow here is way more acceptable in mathematics. That's what I want you to write right there. Alright, I think we're up to our last one, if I'm not mistaken. Here we have another craziness. We can't have a radical in the denominator, so what I'm going to do is rationalize. But the bottom here is like a binomial, right? There are 2 terms right there. So in order to rationalize a binomial, we're going to use this trick called rationalization again, but it's multiplying top and bottom by sort of the conjugate, what they call the conjugate of the bottom. And what that means, the word conjugate, is basically the same number here and the same radical here. The only difference is you change the sign in the middle. If it's a plus down here, change it to a minus up here. So we're going to multiply top and bottom by 4 minus radical 5. And when you do that, you're left with a distributive property. So you're going to take this 2 and multiply it by both terms on the inside. You get 8 minus 2 radical 5 divided by, we have basically have a FOIL. Let me get rid of some of this stuff. We have a FOIL in the bottom. There's a distributive property in the bottom that is binomial times binomial. When you have that, you do your first, outer, inner, last method of distributive property. So the first times first is 16. The outside is negative 4 radical 5. The inside is 4 radical 5. And the last times the last, let me highlight these. This is the last, this is the last. When you multiply those together, you get negative radical 5 times radical 5. But I think we already just said a few minutes ago that radical 5 times radical 5 is just 5 without the radical. Alright, so that's kind of a crazy thing, but it's really easy to simplify. Watch this. The bottom, the whole point of this rationalization procedure is to get rid of the radicals in the denominator, and watch what happens. Negative 4 radical 5 and positive 4 radical 5, they're exact opposites, so they cancel. So your denominator now is just 16 minus 5. So it's 8 minus 2 radical 5 over 16 minus 5 is 11. And none of that stuff can be simplified anymore. So we are good to go. That is our final answer. So there you go. There were the skills that you'll need in order to be successful in my class this year. Now, the skills that you see on this list are not, like I said, the only skills that you'll need. This is definitely not a complete list, but you know, if you saw skills on here that you are not so good with, you can certainly seek help from me during office hours or during class. And you can also continue to seek help online. I have videos on my page that address some of these skills, and you can certainly cruise the web for other resources, particularly the Khan Academy YouTube channel, and one of my favorites is a YouTube user by the name of Patrick JMT. He has thousands and thousands of videos, all of which are really, really well done, so check his stuff out. But hope you enjoyed this video, and I look forward to having a great year with you guys. Talk to you soon.